The new section is entitled Undetermined Coefficient. I'm going to use what's called the superposition approach. Basically, you find their homogeneous solution and then you guess at what their particular solution might look like. So for example, if you have y double prime plus 3y prime plus 2y equals 6. And this is differential equation that you're being asked to solve. Well, step one is to solve the homogeneous equation. That is, instead of equals 6, we say it equals 0. So this problem is of the section before. We just go n squared plus 3m plus 2 is equal to 0. I want two numbers that multiply out to 2 that add up to 3. 1 and 2 do that. So it's n plus 1 times n plus 2 equal to 0. So either that's 0, you need to know additive inverses. You add two numbers, we are adding, you add two numbers and you get 0, the two numbers have different signs. This is plus 1, then that must be negative 1. You are adding two quantities, m and 2. You're getting 0. Since that number is plus 2, 2 is positive 2, I mean to say, then m must be negative 2. So the homogeneous solution, since we got two real roots, is y is equal to c1 e to the m1x plus c2 e to the m2x. That's the homogeneous solution. I'm going to write that down up here. So what we've just done is review from last section. Now I'm going to erase the homogeneous work and we're going to find a particular solution. Now basically we take a second derivative, we add on 3 times the first derivative, we add on 2 times our function, and we just get a constant. The particular solution is just going to be a constant. If you slip, you realize the constant is 3. Well, if y is c, then y prime will be 0. Derivative of any constant is 0. And in the second derivative, the derivative of 0 is once again 0. Now, we plug this into the original equation, and we solve for c. Y double prime is 0, plus 3 times y prime, which is 0, plus 2 times y, where y is c. And this is supposed to equal 6. Well, that's 0, and that's 0. And when you add those zeros, you get 0. You add 2c, you get 2c. 6. 2 times 3 is 6. So c is 3. That is, a particular solution to that top equation is 3. Just to convince you that that's right. If y is 3, then y prime would be 0, and y double prime would be 0. And y double prime plus 3 times y prime plus 2 times y, that really is 6. 0 plus 0 plus 6 really is 6. Okay. So what we can do now is write down the general solution. The general solution is always y is equal to y homogeneous plus y particular. So the general solution will be this. c1 e to the negative x plus c2 e to the negative 2x. That's y homogeneous, and yp is just 3. So there is your solution right there. We guessed that the particular solution would be 6. Now, one can argue, and I tend to agree, that that problem was so simple that maybe it was actually hard. Let's look at another one. Y double prime minus 10y prime plus 25y is equal to 30x plus 3. Our first step is going to be to find the homogeneous. I'll write it down right after the equal sign. So we want to solve y double prime minus 10y plus 25y is equal to 0. That corresponds to the auxiliary equation of n squared minus 10m plus 25 equals 0. You need to know how to factor. That's a perfect square. Two numbers are multiplied. Since there's a 1 in front of the an understood 1 in front of the n squared, we can play the game. What two numbers multiply out to the constant could add up to the number in front of the m. The answer is negative 5 and negative 5. Again, negative 5 or m minus 5 squared. Oh, what do you square to get 0? I don't care what this is called. What can you put between the two brackets and square it and get 0? There's only one answer. It's 0. Regardless of what you put in those brackets, whatever it is, it must be 0. And 5 minus 5 is 0, which tells us m is 5. But it's a double root. And when you have a double root, which means that b squared minus 4ac, where a is 1 and b was negative 10 and c is 25, this was 0. So the homogeneous solution is going to be c1e to the n x plus c2 times x e to the nx. c1e to the 5x plus c2x e to the 5x. That's the homogeneous system, the solution. Now we want to find a particular solution to the original equation, the given equation, the one that remains there. Now, we want to end up after taking multiples of different derivatives. What do I mean by multiples? Here's a derivative, I'm multiplying it by 10. Here's a derivative, it's understood to be multiplied by 1. Here's a derivative, it's the 0th derivative, it's being multiplied by some number. We're just multiplying derivatives by some coefficients, and we're supposed to get 30x plus 3. A guess would be, since this is linear to the first degree, that y would be some linear equation. You'd rather write mx plus b because you're more used to writing a line or a linear equation as y equals mx plus b. Fine, do that. So that's y, and y prime will just be a, and y double prime, a is just a constant, so the derivative is 0. So I'm going to rewrite this equation, except instead of y prime and y double prime and y, I'm going to write the values I have here. So y double prime minus 10 times y prime plus 25 times y. This must equal to 30x plus 3. So we want to combine like terms. First, we don't need that 0. Here we have a number of x's. We have 25a x's. And now we have constants. We have plus 25b minus 10a. They don't have any x's. So we have this number of x's plus that constant. But in the right side, We have a number of x's, and we have a constant. They must be equal. I mean, for example, if I erase the 25a, I better put 30 there. And if I erase this, I have to put -3. That is, whatever goes in that first bracket, whatever goes in here, it must be 30. Whatever goes in here must equal the constant, which is -3. So in here we have 25ax's, and we have 25b's minus 10a's. And we equate them. 25a must be 30. And this mess must equal -3. So if 25a's is 30, then a must be 30 over 25. And I've recognized both of those numbers as being on the 5 times table. 5 goes into that top number 6 times, and that bottom number 5 times. That is what a is. And I know that 25b's minus 10a's should be -3. Minus 10a's, but a's are 6/5, must be -3. So 25 minus 25b minus 12 is -3. You probably should know that 9 minus 12 is 3, and then say 25b is 9. But if you don't know that, add 12 to both sides. The left side is 25b's, and the right side, instead of thinking -3 plus 12, why don't you just see 12 minus 3, which is 9. So b must be 9 over 25. b is 9 over 25. And what I did was fine, but this is plus 3, and somehow it became -3. This should just be 3. Sorry about that. You get to see 2 examples. You should know that 15 take away 12 is 3. That is, this must be 15. If you add 12 to both sides, you'll get the same. So b must be 15 over 25, and 5 goes into each of those numbers, goes in the top 3 times and the bottom 5 times. So b is 3/5. Okay, so now we can have the general solution is the homogeneous solution, c1 e to the 5x plus c2 x e to the 5x, plus the particular solution, which we said was ax plus b, where a is 6/5, so it's ax plus b. And that's the general equation. We equated the coefficients. Suppose you have y double prime minus 8y prime plus 20y, and this is 100 x squared minus 26x e to the x times e to the x. Well, first you solve the homogeneous equation. So it'll be 1m squared minus 8m plus 20 is equal to 0. Since it's 1m squared, I'm going to try to play the m followed by a number game times the n followed by a number game. When it comes to 20, I want the product to be 20, but I want it to be positive 20. So the signs have to be the same, because only a positive times a positive can give you a positive 20, and a negative times a negative can give you a positive. But if the signs are different, you don't get a positive. So the signs have to be the same, and we know if we add two numbers that are both positive, we'll get a positive. The numbers have to be negative. So you look at 1 and negative 20, negative 2 and negative 10. Negative 3 doesn't go into 20 either. Negative 4 does, and negative 5 does. Oh, I already said negative 5. That's when I stop. So this is one pair of numbers I multiply out to 20, a second pair, a third pair. The problem is the first pair adds up to negative 21, the second negative 12, the third is negative 9. They never add up to negative 8. Alright, so we have to use a quadratic formula. Remember that A is 1, B is negative 8, and C is 20. It has to equal 0 to read off the A, B's, and C's. And it's not always, oh, the first number I see is A, the second number is B, the third number is C. No. The number in front of M, that's A, which happened to be the first term I wrote down. The B is what's in front of the M, which is negative 8. The C is the constant. I could have written down negative 8m plus 20 minus m squared, 1m squared. What's in front of, what m squared is being multiplied would be A, what m is being multiplied would be B, the constant would be C. Here, it was not A, B, and then C. Okay, so let us use the quadratic formula to find our homogeneous solution. M is negative B, which is plus 8, plus or minus B squared minus 4 times A times C over 2 times 1. So we get 8 plus or minus the square root of 64 minus 80 over 2. 64 minus 80 is negative 16. The square root of negative 16 is the same thing as the square root of one number times the square root of another number to multiply out to negative 16 when not both numbers are negative. 16 and negative 1. Square root of 16 is 4. The square root of negative 1 is I. Let me tell you what I'm talking about here. You have 30, oops, that's not 36. If you have 36, and I won't disagree that 36 is 9 times negative 9 times negative 4. But you can take the square roots separately and multiply them. The square root of negative 9 is 3i. The square root of negative 4 is 2i. 3 times 2 is 6, times I times I squared. But I squared is negative 1. I get negative 6. The square root of 36 is not negative 6. From this point on, I made no mistakes. The square root of negative 9 is 3i, times the square root of negative 4 is 2i. 3i times 2i is 6i squared, which is 6 times negative 1, which is negative 6. It doesn't equal. What went wrong? Very simple. I broke up the 36 into a product of two numbers that equals 36, where both of them were negative. They can both be negative. Okay, so back to our problem. The square root of negative 16 is 4i. So I have 8 plus or minus 4i over 2. Well, 8 over 2 is 4 plus or minus 4i over 2 is 2i. So my formula, that's my A, that's my B. So now I can write down the homogeneous solution. Y homogeneous is e to the ax times c1 sine of bx plus c2 cosine of bx. That's the homogeneous solution. And again, this is review from last section. What's not review is how we find the particular solution. Why particular? So what happens is the right side is the sum or difference of those two type of terms. To get 100x squared, which is a quadratic, you should write down a generally quadratic. Ax squared plus bx plus c. Plus, to get x e to the x. So we've used letters A, B, and C, so I'll use D, E, and F from here on. But I won't use E because E represents the number E. So I'll have dx e to the x, and I'll also have e to the x. But I won't use E like I said, I'll use F. I have a sneaky feeling, and I could be wrong, I have a sneaky feeling that having an e to the x is also good. The reason is when you take the derivative of x e to the x, the product. First I take the derivative of x, which is 1, times the second. There's my e to the x. Plus I keep the x the same and multiply by the derivative of the second factor. So I'm getting e to the x's. So I just have a sneaky feeling I might need that last term. And if I'm wrong, it's no big deal. It'll just turn out that f is 0. Alright, so now I want to build up this equation, which means I need y prime and y double prime. Now y prime, that is the derivative of this, will simply be 2ax plus b. The derivative constant is 0. Plus, the derivative of dx is d times the e to the x. Plus, dx times the derivative of e to the x, which is e to the x. Plus the derivative of that, which is f e to the x. And combining like terms, well, I have just 2ax's plus just one constant. But when it comes to e to the x's, I just don't have d. I have d plus f, e to the x's, plus dx e to the x. That is y prime. Now let's calculate y double prime. The derivative of 2ax is just 2a, plus the derivative of b, a constant, is just 0. And the derivative of this times e to the x will just be that constant times e to the x, plus the derivative of this. Well, if I take the derivative of dx first, I'll get d times e to the x. Oh, those are more e to the x's. So I'll have d more than just d plus f. And then I don't take the derivative of d to the x, but I multiply that by the derivative of d to the x. And I get that. Now, of course, d plus f plus d is 2d's plus f, which I'll write down. 2d plus s. So that is the second derivative. Now, from this, so I'm going to have this line right here. And I'm going to build this up. Y double prime, which I have right here. I'm going to take away 8y. I'm going to multiply 8y prime. And multiply y prime by 8. Well, there's y prime. Multiply it by 8. Multiply this by, by negative 8. Multiply by negative 8. Multiply that term by negative 8. Now, well, actually, I should just be doing it here. Multiply this by negative 8. I already did. Multiply that by negative 8. Now I multiply this by negative 8. I get negative 8b minus 8f e to the x minus, I multiply this by 8, by negative 8. Negative 8b x e to the x. Okay. And I'm going to add 20 y's. Y's are right there. I'm going to write 20 y's. And I'm going to multiply this by 20. Multiply each of these terms by 20. So I get 20 ax squared plus 20 bx plus 20 c's plus 20x e to the x, 20x b to the x. Plus 20f e to the x. Okay. Now, I am going to add these three. And when I add on the left side, y prime, double prime, minus 8y prime plus 20y, I get this. I know I do. That's what they told me that equals. 100x squared minus 26x e to the x. And I add the right-hand side. When I add the right-hand side. Now, just want to get rid of this so it's not in the way. I'm adding those three lines. And the constant is 2a. And 2a minus 8b plus 20c. So let me write that up here. 100x squared minus 26x e to the x is 2a minus 8b plus 20c, and more. Minus 8b plus 20c. Now, how many x's do I have? Well, I have 20bx's, and I am taking away 16ax's. Notice I backed it out there. Now, how many a squares do I have? Sorry, x squares? Just the 20. And if I'm wrong, 20a, excuse me. If I'm wrong, that is, if there were more, they won't be crossed out at the end, and I'll say, oh, I forgot to include those. Now, how many e to the x's do I have? Not x e to the x, but just e to the x's. Well, I have 2d plus f right there. I have minus 8d minus 8f, minus 8d minus 8f, and I have plus 20f, plus 20f. That's how many e to the x's I have. Now, how many x e to the x's do I have? Well, there are some. I have plus d of them, and I'm taking away 8d of them, and then I'm adding back 20 d's of x e to the x. So let's combine like terms within those brackets. The first bracket, there's no like terms. It's 2a minus 8b plus 20c. That's the constant. Plus the second bracket, nothing to combine. That's how many x's I have. Third bracket, obviously nothing to combine. But then the next two I do. For example, I have 20f's. I take away 8 of them. That leaves me 12. Plus one more f. That's 13f's. And if you have 2d and you take away 8 of them, you're at negative 6d's. That's how many e to the x's I have. Now how about x e to the x? Yeah, 20d's minus 8d's is 12. Plus one more is 13d's x e to the x's. So now we equate coefficients. This right-hand side is really 0 plus 0x plus 100x squared plus 0 e to the x's. So maybe I didn't need that term. Well, actually, I take that out. We'll find out in a moment. Minus 26x e to the x. That means the constant is 0. 2a minus 8b plus 20c is 0. And how many x's do I have on the left side? I have 0. So on the right side, I have to have 0 x's. So 20b's minus 16a must be 0. Okay. How many x squares I have on the left side? I have 100x squared. So the 20a must equal 100. And on the left side, I have 0 e to the x's. The right side, I have 13x minus 6d e to the x's. Well, that must be 0. And on the right side, I have 13d x e to the x's. On the left side, I have negative 26 x e to the x's. So 13d must be negative 26. And this is what we want to solve. From here, we want to solve for a, b, c, d, and f. Well, I know what to multiply 13 by to get negative 26. What I'm multiplying 13 by, when I'm multiplying 13 by is d, it has to be negative 2. 20 times this unknown number is 100. Well, I know 20 times 5 is 100. So a must be 5. Now, since this equals 0, I can make the number small. I can divide both sides by 4. So I get 5b minus 4a is 0. Well, that's 20. A is 5. That is 5b's minus 20 is 0. So that must be 20. 20 minus 20 is 0. Well, if 5b is 20, b must be 4. So let me just write it here. b is 4. We have a, b, and d, so forth. Let's find c. Let's use the first equation. Let me get rid of this because I need the space. 2 times a, since a is 10, sorry, since a is 5, 2 times a is 10, minus 8b's. 8 times 4 is 32, plus 20c is 0. Well, this is negative 12. Negative 12 plus 20c is 0. If you add two numbers and you get 0, add, it has to say add, then the numbers must be opposite signs. They're additive inverses. If this is negative 12, well then that must be positive 12. 20c is 12. Divide by 20, that's c. But of course, 4 goes into both of these numbers. So I conclude that c is 3/5. And of course, I have a little typo, sorry. Just arithmetic error, sorry. That should have been negative 22. So then this should be positive 22. I get 22 over 20. 2 goes into both of these numbers, 11 and 10 times. So C is 11 over 10. So let's go over this. I have A, I have B, I now have C and D. I just need to find F. And I'll use this equation. 13F's minus 6D's. D is negative 2. Negative 6 times negative 2 is positive 12. Well, if the sum is 0 and this number is 12, then the 13F's must be negative 12. And F is negative 12 over 13. Okay. So I have what A, B, C, D, and F equals. And just have to remember that when I wrote down what y equals, I said it was ax squared plus bx plus c plus dx e to the x plus f e to the x. And notice that f was not 0. That is, I really needed that term. So the solution, the general solution would be a, which is 5x squared. B is 4, so it'll be plus 4x. C is 11 over 12, 11 over 10, excuse me, plus D, which is negative 2. And instead of adding negative 2x e to the x, I can just take away 2x e to the x, plus f, which is minus 12 over 13 e to the x. That would be the solution. I equated coefficients. Very similar to what we used to do, and still do when it comes to solving a problem using partial fractions. Try another one. Suppose you have y double prime plus y prime minus 6y is some function of x. The first thing we want to do is find the homogeneous solution. That is, we say that this is equal to 0. And then it's of the type of the last section. You have m squared plus 1m minus 6 is 0. There's an understood 1 there. Since there's an understood 1 in front of the m squared, I'm going to try to follow the m followed by a number times m followed by a number game. And the two numbers should multiply out to negative 6 and add up to 1. Well, positive 3 and negative 2 multiply out to negative 6 and they add up to 1. So this should be 0. And either n plus 3 is 0 or n minus 2 is 0. Otherwise, that product couldn't possibly be 0. And it's wonderful when you're adding. If you're adding two numbers, and you know one of them, and you get 0, then we know the other number. 3, not because of that sign, not because of that addition sign, but 3 is understood to be positive 3. So the n must be negative 3. For the record, that 2 over here is positive 2, even though it says minus in front of it. If you subtract two quantities and you get 0, you should write down this quantity and that quantity, and then put two horizontal lines in between them, because they're equal. So we get two real solutions, so the homogeneous solution is done. It's C1, E2, I'll call that M1 and M2. C1e to the M1x plus C2e to the M2x. So we have the homogeneous solution. We use the technique of the last section. Now what we want to do is find a particular solution. Now, what might you let y be? So when you compute y double prime and y prime and just y and add them up with the correct multiples like 1, 1, and negative 6, you'll get cosine 3x. Remember, if you take the derivative of sine of 3x's, you get cosine of 3x. You take the derivative of cosine of 3x, you'll get a multiple of sine of 3x. So negative 3 sine 3x. And I think I said if you take the derivative of sine of 3x, you get cosine of 3x. You'll get a multiple of cosine of 3x, namely 3 cosine 3x. So I'm going to let y particular be a linear combination of cosine 3x and sine 3x. That is, some number of cosine 3x plus a number of sine 3x. And I just want to find a and b. Well, this equation right here, at least the left side, tells me I need y, which I already have, up to a and b. I need y prime and y double prime. So I'm going to calculate them. Y prime would be negative 3a sine of 3x plus 3b cosine of 3x. And the second derivative would be negative, that is the derivative of this, would be negative 9a cosine of 3x minus 9b sine of 3x. And it's good that everything in blue in the bottom are two things that I want to add. And now I'll write down what negative 6y is. Since that's y, I will just multiply it by negative 6. Negative 6 cosine 3x minus 6b sine 3x. And when I add these, when I add the left side, as it says right here, get cosine 3x. Y prime plus y double prime, which is the same as y prime plus, the same as y double prime plus y prime, minus 6y. This is cosine of 3x. And on the right side, I'm going to get a multiple of sine of 3x. I'm going to get some multiple of the cosine of 3x. Well, how many sine 3x's do I have? Well, I have negative 3a here, and I'm taking away 9b, and I'm taking away 6b. So I didn't leave enough space, sorry. I have negative 3a, I take away 9b, and then I take away 6b. And cosine 3x's, how many of them do I have? Well, I have positive 3b and negative 9a and 6a. Now, the left side you have to realize is 0 times the sine of 3x, which is 0, plus 1 times the cosine of 3x. That's just cosine 3x. And the right side is, combining like terms, you have negative 3a minus 15a sine of 3x. And over here, you have 3b's minus 3a's. Negative 9 plus 6 is negative 3 cosine of 3x. We'll make sure this is right. Minus 3a minus 9b minus 6b. Looks right to me. Then for cosine, we have 3b minus 9a minus 6a. Okay, so of course something's wrong because I wrote down plus 6a. The only problem is I worked this out already and I'm still not getting the right answer, which is lovely. Sure, I don't have any typos anywhere. Okay, so now this must be 0 and this must be 1. So 3a plus 5, of course, negative 9b minus 6b is negative 15b. So multiplying by negative 1, we have 3a plus 15b is 0. And on the right side, we have 3b minus 15a is 1. I could divide this first equation by 3. So I get a plus 3b is 0. Now, these two equations, if I just subtract them, this is going to leave. Negative 15a minus a is negative 16a. 1 minus 0 is 1. So a is negative 1 over 16. Okay, so we have a. Now we want to find b. Well, I know that when I add these two, I get 0. So if if a is that number, if a is negative 1 over 16, then this number, regardless of how it looks, must be positive 1 over 16. Dividing by 3, I get 1 over 48. Okay, coming back to the second line, I'll plug in what A is and what B is. A is negative 1 over 16, and B is 1 over 48. Alright, so now the very, very last thing. Once you have the y homogeneous and the y particular, you're done. Once you have y homogeneous and y particular, you're done. Y general is y homogeneous plus y particular. That is, it's c1 e to the negative 3x plus c2 e to the 2x. That's y homogeneous plus y particular, which is that equation. 1/16 cosine 3x plus 1 over 48 sinus 3x. Okay, understand the concepts. Don't worry about a silly arithmetic error here and there. Sure, you'll lose a point or two on your exam, but it's more important that you understand it. Okay, let's try at least one more problem. Suppose you're given that y double prime plus 4y prime minus 5y is 35e to the say negative 4x. We'll make this an initial value problem. Y is 0 is, call it positive 3, and the derivative at 0 is 2. Let's not worry till the very, very end about the initial conditions. Let's find the homogeneous solution to this corresponding equation. That is y double prime plus 4y prime minus 5y is 0. And squared plus 4m minus 5 is 0. Want two numbers that multiply out to negative 5 but after 4. And those two numbers are positive 5, negative 1. Then m is negative 5, m is 1. So the homogeneous solution is done. It's c1 e to the m1x plus c2 e to the m2x, which is 1x, so just x. So I'll put y homogeneous here. And that part is done. Now I want to find a particular solution. I want to find a particular solution to the equation right above there. And what I will think is, it's just going to be a multiple of e to the negative 4x. So I need the first derivative and the second derivative of this y that I just wrote down. So y prime will be negative 4a e to the negative 4x. And the derivative of that will be 16a e to the negative 4x. Now I can write down the equation above this using those substitutions for y prime, and y double prime. So y double prime plus 4 times y prime minus 5 times y. This is supposed to equal 35e to the negative 4x. So I'll just clean this up a little bit. We have 16a times e to the negative 4x. Positive 4 times the negative 4 is negative 16a e to the negative 4x minus 5a times e to the negative 4x. And this is equal to 35e to the negative 4x. Well, if you have 16 of these, and you take away 16 of the same things, they cancel out. We just have negative 5a e to the negative 4x is 35e to the negative 4x. And I should have said from a few moments ago that all I need to do is know what a is. And then I have y particular. Well, I have this multiple of e to the negative 4x, and it equals to that multiple of e to the negative 4x. Those should be equal. Negative 5 times some number should be 35. And we know 5 times 7 is 35, but that's not 5. That's not 5. Not 5, not 5, not 5. Negative 5. So that should not be 7. It's negative 7. Okay, so I now know that y particular is negative 7 e to the negative 4x. So y general is going to be y homogeneous, which is right above what I'm writing. That's y homogeneous plus the particular one, which happens to be negative. Negative 7e to the negative 4x.